This is Honors Pre-Calculus Final Exam Review 2013. We're looking at number 65, 66, and 67. So to go through one of these in detail, you should go back and look at the video for number 64. I go through that one in detail. On these ones, since they're all very much the same thing, I'm just going to look at some general ideas. So for each of these, we have a function that involves cosine or sine. So what you need to do with these kind of functions is you need to be able to look at the sine or cosine function. So we have a number in front. For example, if we line this up with this one, our a is 1/4. We could have either sine or cosine here. So in this case we have cosine. And then we have a bx, in this case the b is 1, and a c. Now actually on this one we need to distribute the 2 first so that it can match this format more closely. Same with this one, we're going to distribute the 4 first, and then it will match bx plus c. So the b will be 4, and the c will be 4 pi over 3. Actually, negative 4 pi over 3. On this one, we don't have to do that. There's nothing to distribute out here. All right, so for each of these, we're going to be looking at the function. It's a number in front, and then the sine or cosine, and then bx plus c plus d. We want to remember that the a is the amplitude. When we say what the amplitude is, we want to use the absolute value. So if we had -2 here, we would say the amplitude is +2. So the number in front of the coefficient of x, the number in front of the x is the b. It's also called omega, and it's the frequency. We use the omega to get the wavelength, which is also called the period, and that wavelength or period is called lambda. It's related to the frequency by 2 pi over omega. And then we can also use that 2 pi over omega, that's lambda, we can use it to get the k that we use for our key points. K is equal to 1/4 lambda. And the d up here is a vertical shift. With the c, we use the c to find the phase shift by using -c over b. That'll give us our phase shift, which we sometimes call phi. And then if we follow this arrow back behind, the phi is also our starting point for our key points. So now if we look at our key points, so we start with the phi, or we start with the x coordinates. The phi is the first x coordinate. We look at our k that we found as 1/4 lambda, and we add that k 4 more times so that we have 5 key points altogether. And that'll be our x coordinates. For the y coordinates, we start either, if we have a sine function, we start with 0, 1, 0, -1, 0. Or for a cosine function, we start with 1, 0, -1, 0, 1. So that'll be our starting point depending on which function we have. Then from that starting sequence, we will take our a from up here, not the absolute value, but the actual a. So if this was -2, we would use -2 down here and multiply. So first we would multiply our sequence times the amplitude, and then we would add whatever the vertical shift is. And then we get our y coordinates. So now we have 5 x coordinates and 5 y coordinates. We put those together and make points, the points x, y, and we plot them on the graph and then connect them with a nice sine curve. So this is the general idea of the things that you use to graph number 65 through 67. Remember to distribute this 2 in first. So it will at first immediately look like y equals 1/4 cosine of 2x plus, and when we go 2 times pi over 4, that's going to be pi over 2. So we'll start by doing that, and then we'll match it up to our format. And that's how we graph all of these. And again, if you want to see detail, look at number 64. But that's all we're going to say about these ones.